Hello, everybody. So, I was getting some questions via email that told me that we need to understand the image of a map better. So, the image of a map is a set of all possible outputs. But what does that mean? Well, let's do an example. So, I'm going to define a function named f, and it's going to have an input that I named theta. And what it's going to do is it's going to return cosine of theta times the sine of theta. Okay, so now I have a function, and let's call it at 0.1. I get a vector in 2 dimensions. Okay, and so what I can do is I can plot that vector as a point. Right, so it's a plot in 2-dimensional space. Here it is. Its x-coordinate is almost 1, and its y-coordinate is a little bit above 0. I could instead plot 0.3 and get a different point. I could plot 0.7456, get a different point. You see it's sort of moving around. But what if I'm going to save this plot, and I'm going to add to it another point, f of 0.1. And now I'm going to add to it another point. Oh, now I have to show the plot. So now you see I have 2 points. Right, because I gave it this input, but I could have given it a different input. And so we could keep doing this. We could just keep plugging things into f, turning them into a picture. And we're going to keep getting more points. Now, the image of a map is a set of all the possible outputs. So these 3 points are part of the image, but the image includes many, many more points. And what are they? So I'm going to do a for loop for theta in S range from 0 to 3.14 by an increment of this much. Or how about this much? Do what? Well, add the point plus equals this point. And now show it. Okay. So you see all these points are part of the image. In fact, I can go to 2 times 3.14 and get even more points. And in fact, we're starting to see the image now. Let's do more. I was stepping by 0.1. I was going from 0 all the way to 2 pi by increments, by steps of 0.1. So let's do even smaller steps. Well, it's taking a little bit of time. There we go. Now we're seeing the image. The image of this map is a set of all possible outputs, but it's just this circle. So particularly, this point here, 0, 0.5, right here where my cursor is, that point is not part of the image. Okay? So here we have a map. I'll just put it a comment. It maps R to R2. And so the image of this map is a curve in the plane. We could change the map, and we get something else. So, I don't know, will this work? I just give it now a 3rd dimension, and now it's a map to R3. It should be a curve in space. What will it do? Oh, so here's now this curve in space. This is the image of our new map. It's a helix. Interesting. Okay. And actually, I could keep plugging in more and more numbers, and we'd see the image includes even more points. The helix will keep spiraling. It'll keep spiraling. So let's do 10 pi. Is this going to be too much? Maybe it's going to be too much. I don't know. Oh. Well, computers sometimes have... Oh, there we go. So you see that this curve is the image of that map. Okay? And that's pretty fun. That's pretty fun to do. So the image of a map is a set of all possible outputs. Now, you see this curve is not a linear surface because this map is not a linear map. And so let's look at a linear map. First, here are a bunch of points in my input space. So I'm gonna talk about a map from R2 to R3. Okay, and here is part of the image of this map. What it does is it takes R2 and all these blue points, and it sends them to R3 and all these blue points, okay? Now, how does it do it? Well, what it does is it sends this vector, this red vector is E1, and it sends it to this vector in three-dimensional space, 1, 1, 1. So that is this red vector. And then it takes the green vector, which is E2, the vector 0, 1, and maps it to this vector in three-dimensional space, 2, 3, -1, which looks like this, that green vector. And then the map maps all of R2, so I can take all these points, these blue points, and I map them to what? So the first coordinate of the blue point and the second coordinate. Python is 0 indexed, so C0 is the first coordinate of one of these blue points, and C1 is the second coordinate of one of those blue points. And then I plot it, okay? And you see that this is a linear map. This is a linear combination of vectors. And that's how we see that the image is flat. The image is linear. The image is a plane in R3. So the image of a linear map is a flat space. It could be a line, it could be a plane. And the image of a nonlinear map, like this one, there's a nonlinear map, might be a curve, okay? So this is the image of a map. It's a set of all possible outputs, and it lives inside the output space.